Hello and good morning. Welcome to the Summer School 2024 from my side. Today we will hear a lecture on remote sensing and we will start with definitions and history. First of all, let me introduce myself. My name is Martin Otschipka. I'm professor of remote sensing and digital image processing at the University of Applied Sciences in Dresden. After completing my studies in cartography in Berlin, I continued working at the German Aerospace Center, in the beginning at the Institute of Planetary Exploration and later on at the Institute of Robotics and Mechatronics. In 2007, I did complete my PhD at the FU Berlin in geography. In 2011, I did change to the Institute Freshwater Ecology and Inland Fishery. Since 2012, so for 12 years, I'm working at the University of Applied Sciences in Dresden. Lectures are separated in two parts. One part is presented by me. It's a general overview on remote sensing, and the second part is about applications in archaeology, which is presented by Tim Karberg. Within the first part, we will have several topics. First, we will talk about definitions and history, electromagnetic radiation, including atmospheric effects, terrain reflections. We will talk about satellite orbits and georeferencing. And later on, we will talk about the hardware section, remote sensing, sensors passive like push broom scanners and hyperspectral sensors. And we complete with active sensors like airborne laser scanning and radar technology. Remote sensing in general is the process of acquiring information about an object or phenomenon without making physical contact with it. It is typically done by detecting and measuring the radiation that is emitted or reflected by the target object, so the Earth's surface. The measurements are not executed directly, but in an indirect way. They're captured from a distance, usually using satellite, aircrafts, or UAS. Photogrammetry could be defined as a part of remote sensing, and it's about the process of obtaining information about the physical characteristic of objects and the environment through recording and measuring and interpreting photogrammetric or photographic images or phenomena. So in photogrammetry, it's more about geometry and not that much about spectral information. Another topic is aerial image interpretation, so visually interpreting informations in aerial photography. This could be qualitative and quantitative analysis. It's done by logical combination and the individual experience of the interpreter. How could we take measurements in our natural environment? This could be done by direct measurements like meteorological measurement stations, or it could be done by measurements at the location, but the information could be transferred with wireless technology or the mobile telephone or mobile communication network. In remote sensing, the measurements are taken from afar, so from helicopters, aircrafts, and UAS. We can distinguish two types of sensors, passive and active sensors. Passive sensors receive and record radiation information The radiation source is the sunlight or the emitted radiation by the Earth's surface. Typical examples for passive sensors are Landsat, Sentinel-2, IKONOS, and so on. Active sensors use the object as a reflector. Radiation sources are electromagnetic radiation emitted and received by the sensor, typically radar or LiDAR technology. Within remote sensing data, you find a large variety of image data. On the left-hand side on this slide, you see an aerial photography from the center of Munich. The geometric resolution, so the size of a pixel, is roughly about 5 centimeters. On the right-hand side, you see a meteorological satellite image in the infrared spectral band, and the geometric resolution here is about 1 kilometer. So let's travel a bit back in time. So within cartography, we find beautiful petroglyphs, roughly about 3,500 years old in Italy, showing a map in a bird's eye view with buildings, roads, and so on. So people always tended to map things, even if the technology for flying or seeing with a bird's eye view was not available. People were able to draw maps. Later on, we find other examples like this here of the city of San Francisco, a bird's eye view created in 1878, showing roads, the harbor, and a large amount of ships in front of the coast. With captive balloons, it was possible to fly, and in addition to that, with development in photography, first aerial pictures were taken by this Frenchman, Gaspard Félix Tournachon. He was a famous photographer, photographing many stars like Sarah Bernard on the right-hand side, but he also loved to fly and take aerial photographies. On this slide, we see several examples. As you can see here, we see impressions of the city of Paris, and we also see here a change from artists' impressions to mapping. So later on, the oblique aerial images were illustrated with letters showing street and place names. In the beginning, nobody really understood what Nadar discovered, and so the newspapers made fun out of him, and I found this drawing in the net about Nadar and taking aerial photographies of Paris. On this slide, you see a view of Boston recorded in 1880, one of the first pictures taken in the United States. Many more aerial images were taken. Here's an example of the pyramids of Gizeh. I think the aerial photography is of a high quality, and you can see here it will be a great success taking aerial photographies also from remote areas or countries far away from Europe. Another idea came up with Gustav Neubronner. He was operating his aerial cameras using pigeons. Unfortunately, the technology was quite demanding because pigeons fly just where pigeons fly and not necessarily over the target area. Still, we can find some examples about these photographs. On the top left side, you see the wings of the pigeon in the aerial photography. Below, you can see an impression of Frankfurt, and many other images are still existing. With the developing movie industry, another guy, Mr. Mester, was very successful in transferring the technology from the movies to aerial photography. In this example, you can see one of the first mosaics created by Nadir Images. During that time, the first aerial images in color were recorded. Here's an example of the city center of Berlin. Later on, aerial images were also recorded in the colonies. Of course, aerial photographies are of a great use for mapping and basically controlling another countries. So here's an example from Indonesia, the temple of Borobudur. Also, with the new technology of aerial photography, it was possible to map remote areas like this picture here taken in Siberia. It was used for ecological soil research in 1932. The discovery was here that we can see things from afar sometimes better than from the ground. So aerial photography was understood there as a useful tool for analyzing landscapes. During World War II, aerial photography, of course, was of a great importance. You can see in this example the battleship Bismarck, and the aerial photography on the right hand side is known as the photography that sank a battleship, because with the aerial photography the position of a battleship was known and it was easy to attack it. After World War II, lots of aerial photographies were recorded to document the destroyed cities, and as you can see here, a lot of cities, this example is from Dresden, were seriously damaged, so there's not much left here in the city center, and these aerial images are still of a great importance for recovering explosives from World War II. As you can see here on the right hand side, tons of explosives are still recovered. In 1964, Mr. Kolbeis published an article about the use of near-infrared imagery for analyzing vegetation. So area photography was also at a great importance in the Cuban Missile Crisis in October '62. You can see here mapped on a aerial photography the launch sites and the missile transporters and so on. So that was actually a proof that missiles were transported or transported to Cuba. The so-called Corona program using Discoverer satellites was active during 1959 and 1962. The satellite was recording analog photographies, as you can see here on the left hand side. it was recording like panoramic views. These image data is still available for free and could be downloaded from US servers. The only problem with the data is that the georeferencing is not very accurate, so the aerial photographies you can download are not necessarily in the right place, and it's quite time consuming to find the appropriate satellite imagery from this program. Still, it was a great success and it was continued with other. On this slide you can see one of the most famous satellite images showing the Pentagon in the United States. It was recorded in 1960. On the right hand side you can see an aircraft recovering the capsule from the Discovery satellite. The space program was continued with the Gemini missions in preparation for other space missions. You can see here the crew on the left hand side, and on the right hand side you can see one of the first small scale images showing Florida Peninsula, and this picture was of great importance because it was understood that small-scale mapping is of a great importance for environmental monitoring. The Gemini program was followed by the Apollo program with the first manned mission to the moon. You can see here an impression from December 24 in 1968. In 1972, the famous Landsat program from NASA began. It also was known as Earth Resource Technology Satellite during the development, but nowadays we call these satellites from this program Landsat. In this false color imagery, we can see an area in Louisiana. We can see or distinguish between vegetation in red color, water in dark blue and gray, and build-up area in brownish color. Lots of further developments were made in the following years. A famous example is the spot technology from 1986, which played a significant role in commercial remote sensing. Other examples from 1988 are the Indian remote sensing satellites IRS, which played an important role in agriculture, forestry, land use, and disaster management. European missions in 1991 and 2002, ERS and ENVISAT, had a focus on environmental monitoring, so the providing of data from the ocean and ice monitoring, atmospheric chemistry, and land surface monitoring. Later on, the technology was improved, so focusing on a higher geometric resolution. In this example, we can see a so-called Pleiades image with a sub-meter resolution, so it is quite close to aerial photography, and also enhancements in the spectral and temporal resolution were made. Not only Pleiades but also other satellites like worldview satellites offer very high resolution up to 3 decimeters, and also a high spectral resolution. With hyperspectral technology, with the capturing of hundreds of spectral bands, allow detailed analysis of materials like soils or water surfaces. Other improvements were made by a company like Planet. This company launched constellations of small satellites, like very small satellites, the size of a shoebox approximately. And these satellites did operate only for a shorter time, but improved the temporal resolution. Very famous also is the Sentinel program from the European Space Agency. With the Sentinel satellites as a part of the Copernicus program, the focus here is environmental monitoring and disaster management.
25 years ago, Copernicus set out on a mission to transform the way we see our planet.
A lot of data I mentioned before is available for download for free. Please check out the following websites here. You might find Landsat data at the Earth Explorer. You find the Copernicus data, including the Sentinel satellite data at the ESA website. And of course, Google offers interesting videos with time-lapse showing the development for environmental changes, and also with the Google Earth Engine platform, it is possible to apply and create your own algorithms for image analysis. There's a lot of software for analyzing satellite imagery and aerial photography. Some examples we use here at the University of Applied Sciences are ADA's Imagine, but other software packages like Snap from the European Space Agency is suited for analyzing all the Sentinel data. It's for free. Other open source software is GRASS and QGIS, including the appropriate plugins like the Google Earth Engine plugin, allowing you to apply Python scripts to analyze image data. So that was a brief introduction to history and definitions. Thank you for listening, and see you with the next lecture.